Question number 32. An electron is in an excited mercury atom, starting at level G. G unit. What is the minimum energy required to ionize this atom? Sounds like to me I need to go to the reference table. So I'm here at the energy level diagrams, and the problem said mercury, and I am at level G unit. And at level G, I have a negative 2.48 electron volt energy. At level G, we have negative 2.48 electron volts. If I want to excite from G and go up to ionization, I need to gain some energy. I need to go from negative 2.48 to 0. Well, how much is that? 2.48 electron volts. Question 33. A student is standing on an elevator that travels from the first floor all the way up to the 10th of a building. The student exerts the greatest force on the floor when the elevator is doing what? Well, let's draw a picture of this scenario. So there's the scale. The scale, of course, is on the floor of the elevator. The scale is pushing in to the feet of the student, and the student's feet, of course, is pushing down in to the scale. So let's see, at rest. Well, if everything's at rest, everything's balanced, so that doesn't make sense. If we're moving at a constant speed, everything again is in equilibrium or balanced, so that doesn't make sense. So 3 and 4 immediately are eliminated. But I want the greatest force on the floor, which means the feet have to push in the most. So if the feet pushed in the most, that means this elevator, if this elevator is accelerating up, it'll be pushing into the scale, which then pushes up into the feet. If it's pushing into the feet, on top of the feet pushing into the scale, you're going to have a greater reading, so 1 is your choice. Question number 34. At the bottom of a hill, the car has an initial velocity of 16 meters per second. So my initial velocity here is 16 meters per second. The car is uniformly accelerated at negative 2.2 meters per second squared. Well, if it's negative, it's working against us, so the car is slowing down. And this happens for a total of 5 seconds. We want to know how far does the elevator go? Well, my initial speed again is 16 meters per second. My acceleration is a negative 2.2 meters per second squared. My time is 5 seconds. And I want to know how far does this elevator go? Looks like we need to go to the reference table. Since we're talking about a car moving, this is mechanics, and it also deals with acceleration. So if I'm dealing with acceleration, these are the formulas I need. These formulas are used for acceleration or free fall, because gravity is an acceleration. In this case, I'm looking for how far do I move, so I need an equation with a distance in there. And if we look at what I know I'm searching for distance, I know my VI, I know my T, and I know my acceleration. So this is going to be the formula I want to use for the scenario. So D is equal to VIT plus 1/2 AT squared. D is what I'm solving for. My initial velocity is 16 meters per second. My time is 5 seconds. Plus 1/2 of my acceleration, which is negative 2.2 meters per second squared. And my time, once again, is 5 seconds. But don't forget to square it. You end up with a distance of 52.5 meters. Question number 35. A particle enters an electric field between two oppositely charged parallel plates. Which particle will be deflected toward the positive plate? Well, a particle, if it's going to move toward the positive plate, which means it's going to do this, That has to be negative. Why? Because opposites attract, and what's charged negatively? But an electron. Next up, you got 2 for 1. Yes, that's right. Page 7 and 8 all in one video. I don't know about you, but it makes me want to say, let's get it.